What is going on, guys? In this video, we'll be taking a look at Minecraft's core design. And when I say core, I mean fundamentally core. We're going to look at how Minecraft starts up, how everything is loaded, and how physically time works in Minecraft. Like, how does everything continue and how do events happen? We're also going to look at how Minecraft shuts down and makes sure that your computer, does not run out of memory or crash. All of that will be in this video, so let us begin. First, what is Minecraft? If you do not know, it is a blocky, procedurally generated, three-dimensional game. Now, because of this procedurally generated aspect, it has caused over 238 million copies to be sold, which is one of the most popular games. I think Tetris is another one of them, but Minecraft, anyways, is a very, very popular game, and it is pretty much infinitely customizable. Like, there are so many permutations of how you can build stuff, how you can mine stuff, how you can create stuff. It is very popular for that reason. We will be taking a look at Minecraft 1.19 Java Edition, and the reason why it's 1.19 at the time of this recording, 1.20 is still in the works, but 1.19 is available. So we'll use that full released version just to show you guys. And we will assume some things before we get started. First, you need to know Java because we are going to look at the Java edition of Minecraft. You need to have an advanced understanding of computer programming with Java. This is not a Java beginner course. This is how Minecraft works. We're looking at production code right here. Another thing is there are going to be many boilerplate codes. So like there's some things that are keeping track of internal stuff that Mojang uses and other things that are just irrelevant. And that's why we're going to omit these things. Because again, that will make this video like hours long if we keep that all in. And finally, only client-side code will be discussed because server-side is pretty much just all networking. Client-side is what you're actually playing, basically, what the player is actually experiencing. And then all classes, interfaces, and everything else is probably imported. So like the import statements, you don't have to worry about that. We assume it's all like good. And then we will keep some variable names anonymous, so like var1, var2, var3, because again, they're just useless in the discussion. We just want to know the important stuff. All right, so now we are in the packaging aspect of it, because what does every Java function need? Or I guess every Java program, what function does every Java program need? And the answer is the main function, of course. It is the entry point, and this is where all Java programs start. It kicks off Minecraft just like any other Java program. So we have isolated, or I should say, have isolated it down to two packages. So we have the net Minecraft client package and then the net Minecraft server package. So remember, we'll only look at the client side. So we will just take a look at that client.main package. So let's head over there right now. All right, here is what it looks like. So yep, this is the main function for Minecraft 1.19. This is it. Well, this is the beginning. You can see we have this continuation here. But look at this first. First, we're going to, of course, try and detect the version of the game. So this will return something to that regards of 1.19. It might not be 1.19 exactly. There's some internal version numbering going on. But that's basically what it does. And then it's going to create a new option parser object. So this parser will basically take a look at everything you wanted to basically put in before you launch Minecraft. So like we'll see, the version, and then we see the full screen width, the full screen height, user properties, all of that. So like the options you want to specify in the game before it starts. And notice how whenever you open up Minecraft for the very first time, it defaults to this 854 by 480 resolution. So that's where we can see this happening in the Java code right here. So the width defaults to 854 and the height defaults to 480. So that's pretty interesting. After that, we have the actual initialization sequence. So we have a constant reference, the game, which is appropriately called, and it has the type Minecraft. And then we will just define that first, and then we will initialize a render thread. And we'll get into how all the render threads and how all of that works later on. I'll show you how the game loop works. But just know that this is in charge of displaying stuff. And then so we'll get a static method that will initialize the render thread. and then it will begin the initialization. Now, look at this. We will actually instantiate this in this new Minecraft class thing, which again, we have the type Minecraft, and then we pass in game config, which is taken in from all that options. So this game config will look at all the options, and then it will basically feed them into Minecraft. We'll take a look at this in the next few slides here. And then you notice we have a try statement, so there must be a catch statement somewhere, and you're right, there's a catch statement right underneath, and that catch statement is to catch all the thread action going on, because you need to catch a throwable if you want to do anything with threads in Java. So we will see what happens here. First, it will create a crash report. So it will say something's wrong, and then it will add that crash report to the actual section here, and then it will crash with that crash report. So it'll take this var63, which is this crash report up here, and then it will crash with that. And then remember, we're in the main function, so it'll return, which means it'll just end the program. So that's what happens if you crash when you begin loading the game, or not even loading like the world, just the actual like Mojang screen. That's what happens here. The next thing, all right, we're back to that constructor we saw earlier. So that public Minecraft constructor. Now, first thing you notice is we initialize this game object right here, and then pretty much the rest of the things are just instantiations of like every single private field. So we can see instantiations of profiler, metrics recorder, game thread, options. It sets a boolean called running to be true. Gets the random session ID to a random identifier. Basically, just everything you think of is here. Like, look, more stuff. Resource manager, splash manager, music manager, font, window, item colors. You know, you get the point. Everything is instantiated in the constructor. So this basically just creates everything you want and need in Minecraft. So yeah, that's the constructor. Now, let's take a look at the next thing, which is, yes, the game loop. This is by far the most important thing in Minecraft. So all video games pretty much, including Minecraft, use a gigantic game loop. Now, it's infinite unless, of course, you want to just quit, or the game runs out of memory, which in that case, it needs to find a way to stop before your computer crashes. And then, of course, some exception occurs mid-game that causes it to stop. So like some breaking things going on. And then we can find the game loop in the main method. So that main method entry point has that game loop. And the thread.run method we'll see later. Now, these two things are important because they're different. The main method's game loop and the thread.run's game loop, they're essentially the same thing, but they have drastically different contents. We'll look at that later. So here is a little diagram that shows what that game loop is all about. Now, the interesting thing is yes, the human player is the final aspect, and it completes this game loop, like this loop, like the actual circle you see. Because you, assuming that you're actually playing, when something happens on the screen, you decide to do something. And that's represented with the keyboard and mouse. So you input, and then the input goes through this game state, and the game state we'll see again in here is this thread.run method. It will process that game state with a certified tick rate, and we'll see that tick rate later on. And then that tick rate and every game state will send geometry to render stuff. So like it'll update the screen, which of course that will be your frame rate. So the tick rate is the behavior aspect of your game, or Minecraft in this case. And the frame rate is, of course, how many frames, how many pictures there's going on in 1 second. So the render frame deals with frame rate, and then we're going to not look much with frame rate, but we're going to look more with tick rate. So we'll look at that later. But yes, you are part of that game loop. So here is Minecraft's game loop. This is in the main method. So we're going to create a game thread. This is the core central thread. This is the backbone of all game threads. So this is important. And we're going to basically, again, looking at this diagram here, when we create a new thread here, we can start it, and then this runnable thing implements or overrides a run method. So this run method tells the thread how to run. And then, so you can see down here we have this game thread.start. So it calls start, and then it tries to initialize the game thread, and then it calls this game.run. Otherwise, there's some exception that gets logged. So pretty simple. And then, yep, so we have this run method. And then let's look at the next section in the main method. So this is the actual game loop in the main method. Now, it looks very simple because it's just a while true, which is an infinite loop. And it checks if the game is running, then it just continues the loop. And nothing very useful here, because where is the actual game loop? Like, where does everything get updated? Like, how does everything happen? This isn't clearly the game loop because it's only checking one condition. Of course, that is in the next slide, is Minecraft.run, which again is that other run function here. So in the real game loop, which is of course in Minecraft.java, is this run function. Now this run function is a very important function because it really does the heavy lifting of Minecraft. So first, it looks at the processor, like performance of your computer, because if it's greater than 4, then we allow Java, or Minecraft in this case, to have max priority. That's what that 10 means. It's actually an enum, but it's just 10. But if it's less than 4, then we can't really hog up all your CPU resources. So that's what this is doing. Next, we will look at the fundamental logic. So here we go. We see this while that running thing is going on again. That's what we discussed earlier in the game loop section. And then we will see that if the game is crashed, then return, which means just stop the game loop, and then add a crash report. So that's pretty simple. Down here we see if it doesn't crash, so we continue on, we see that it constructs a profiler, which basically just allows you to look at the performance of your game. So when you press F3 and all of that, I believe it was Alt or Shift F3, I think Alt F3, you see the FPS pie chart, all of that. And then it will start the metrics recorder and profiler. This, again, is for performance reasons. And blue arrow here, this is very important. This runs a single game tick. So this little method call right here is very, very, very important. This is where everything happens. So we'll look at what that game tick means later. So what happens if the game runs out of memory? Well, first, it will be, out of RAM. So this is what happens when you just decide to use too much Forge module, I don't know, or something like that. It will try to form an emergency save of your world so that you don't lose everything. And then it will display to the player that you run out of memory. So I think you've probably seen that before when you're playing Minecraft, or maybe not, depending on what system you're using. And then this is interesting. So it will suggest the JVM to collect garbage. Now what this actually is system.gc doesn't actually free memory. It just basically tells the virtual machine to be like, okay, can you, collect your trash a little bit? It's getting a little bit clogged up. But the JVM can ignore that, so I don't know why that's there. Maybe it's just like Hail Mary last attempt to basically collect some garbage. Other than that, it logs the incident for future reference and debugging. And then this is interesting. So it sets this emergency flag. We're going to discuss what this flag equals true does in the next section. Okay, so there is a failsafe. In case the memory runs out, we see this happening here in that catch block. We set the flag equal to true. Remember, in the try block, we see that very important blue arrow call. That is this dot tick, run tick, not flag. And then this is that failsafe mechanism. So let's look at this diagram. So basically what this is saying. Does the game still have memory? If it does, then the flag remains false because, again, it's running. But since we passed in not flag evaluates to true. And since it evaluates to true, it becomes this dot tick, run tick, true, which means, yeah, run the tick. It's true. Let's run the tick. If the game runs out of memory, then we set this flag to true. But since not true equals false, this dot run tick not flag becomes this dot run tick false, and then therefore run tick stops running because, again, it's false. So it's pretty simple how one Boolean variable can basically stop Minecraft immediately, because otherwise you really can't do anything when you run out of RAM. Pretty much you just either have to like hope Task Manager works, otherwise you just have to restart your computer, which is not good. So Minecraft actually prevents this. All right, let's look at that game tick, which is discussed in that previous section. So a tick is the most fundamental unit of time in Minecraft. It is responsible for keeping time, basically. It keeps everything in sync, and it usually runs at 20 ticks per second, which means each tick is 0.05 seconds. So we can see that being instantiated here is such that 20 ticks per second as a float value in this timer module here. And then we can calculate that each in-game day lasts for exactly 24,000 ticks or 20 minutes. So that's common knowledge. We all know that. But if the computer is unable to keep up, there will be fewer in-game ticks per second. And that's where you see the mobs lag and other stuff start to break. So everything needs ticks. Moving objects, minecarts, mobs, zombies, ender dragon, mob behavior. So like if the ender dragon decides to shoot anything at you or maybe perch, all that requires ticks. Your health and your hunger, of course, also require ticks. And then the weather and pretty much everything else, like terrain updates, how fast grass spreads, all of that. So here is that run tick method. Again, there's that Boolean flag again, where we had that failsafe. And then we're going to advance the time by delta t, which is usually, again, that fixed time frame of 0.05 seconds. And then down here, we see that we call this .tick function. So run tick calls the tick function. So I think this is a pretty self-explanatory method. So this run tick method actually runs the tick method. But what does this tick method do? You see, the common pattern when we're analyzing Minecraft's code is we have to jump around a lot. So let's go there. This is that tick method. Again, notice how I said inside Minecraft.java. This is because the central tick method calls many other tick methods in their respective areas. So look, we have the GUI.tick, and then we have Gamer.tick, and TextureManager.tick. This is a very, 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 and I can't stress this enough, very good design pattern, because if you put everything in this one gigantic tick function, then there's no way of knowing what function actually caused the problem. Let me show you what this means. So look at these statements. So we have a screen.tick. This exists inside that original tick function earlier. And then level render.tick, music manager.tick, particle engine.tick. They all got called somewhere, right? And what happens if, music manager fails, right? So we see that the music manager controls music, or the particle engine controls, like particles. It would not make sense to put them all in this gigantic function, because if the music manager fails, right, it has a bug, we can look at the stack trace, we can see, oh, it's called from this music manager.tick function. And then we can, fix that. But if we put them all in this gigantic tick function, then it could be anything. It could be in the particle engine section. And also, plus, it will just be a billion lines long if it's all in one function. And that file will be hard to read for humans. All right, so let's look at this interesting tick logic right here. So this is a part of a module's tick function. So this handles the player pretty much. So we check to make sure if these things exist. And then the interesting thing is if the screen is null, so if we don't have anything to display, we check if the player is dead or dying. And if it is, then we set that screen to null. And then if it isn't, and if the player is sleeping, you can see we have this in-bed chat screen. So that's when you click that bed button, it brings this up. Down here, if the screen is something, so like it isn't a null reference, we set that to this.screen, and then we see if it's an instance. So if it's already a bed chat screen, then we check if the player is not sleeping, then we wake the player up. I know these functions and methods are named weirdly, but that's basically what it does. So let's look at a creeper's tick method. So this is just for the creeper again, even though we don't see that right here, but it's in that creeper class. So this is overriding that generic tick function. So we'll look at what's going on here. First, of course, it makes sure the creeper is alive. If it is alive, then we look if the creeper is ignited. So like if we get too close, then we start to make the creeper swell. If the creeper starts swelling, then we create this primed hissing sound. That's that dreaded hissing sound when you hear. And then it'll prime the fuse as a game event. So it'll start priming. And then finally, down here, if this max swell is attained, then of course we explode the creeper. But we have to make sure it's all in sync. So we do super.tick just to make sure, like, hey, did everybody else get that? Just so you guys know, the creeper is now dead and exploded. So that's what the super.tick does. It ensures, again, everything's synchronized. All right. The final thing we're going to look at is stopping and cleanup. Look at this right here. We have this shutdown thread that will initiate the basically shutdown process, and then it will look at this halt method right here. So in this halt method, it will do a .join. So this .join basically waits until the server thread is dead, and then it'll continue. So it's going to shut down the server. Obviously, sometimes, for some reason, you can't really shut it down, and therefore it logs that. And then we go back to the main method. So yes, this bracket is literally the literal end of the main method. I just said literally 2 times, but whatever. But you get the point. So first, it will stop the game gracefully, and then it will join the game thread. So again, just wait until the game thread is done, and then it's dead, we continue. And then finally, again, appropriately titled, we do game.destroy. This is literally the last function called before Minecraft truly terminates. So let's take a look at that. All right, we are at the end. This is where it all ends. So you might have seen this if you run a server, this log.info stopping thing. You've probably seen this in that Minecraft server client, but it works the same with the client-side player as well. So first, we look at this level. So level is your world. We disconnect from the level. This is what Minecraft says. And then we close the screen and clean up the window. So basically everything like your Minecraft title screen, your Minecraft, just everything related to Minecraft, boom, gone. And finally, the last thing you'll notice is this classic system.exit 0. So this is the actual last method that will be called, because this tells the JVM or Java itself to exit. If you're on Windows or Linux, it basically tells the OS just like, okay, I'm done, this is it. And of course, if nothing goes wrong, so if there's no abnormal crashes, it returns an exit code of 0, which just tells everybody, you know, we're done, and it has successfully exited, and yeah, and you can basically, again, reclaim the resources. That is the end of it all. So hopefully you enjoyed this deep dive into how Minecraft works. Of course, there are so many other aspects such as terrain generation and how like random loot trading stuff works, but many other people have covered that. I was trying to cover the actual backbone. Without what we discussed in this video, Minecraft wouldn't really be anything. Like nothing will work. No main function, no main method, no tick method, nothing will work. So yeah, if you enjoyed this video, leave a like, give that a thumbs up, double punch it if you will, and then subscribe, and I'll see you in the next one.